Okay, hi everyone, it's me. So in this screencast, what we're going to talk about is the next new topic, which happens to be the last new topic in the exponential and logarithmic world, and it has to do with this, solving these equations. Okay, I'm going to start with, let's just start with some comfortable ones like this one. Let's see, I'm looking at, okay, 2 to the, hi, yes, come on in. I'm just making a screencast, so yeah, come on in, and you can feel free to stay as well.
Molly, someone's in here. I don't know where she went.
Yes, she just like took off. I said, I was wandering around looking for a room to record. She said, you can just use this room. And then she said, she was so funny. I said, well, do you have to do work? And she says, oh, please, no, we're just wasting time. So she was very honest and very, very sweet. Let's see. Okay, so the first thing we're going to do here, when we look at these two equations, okay, this is your first introduction to solving equations that are exponential and logarithmic, okay? So exponential equations. Why are equations, or how do you know when an equation is exponential? Because the variable that you're solving for is up in an exponent. All right, this equation over here is a logarithmic equation. The reason why this equation is logarithmic is because the variable that you are solving for is within the argument of the log. It's really important for us to be able to not only identify what kind of an equation it is, but also talk about why. All right, so now I'm going to go through the steps that you want to work through when you are solving an exponential equation and a logarithmic equation. So step number one, when you have an exponential equation, the first step is to isolate the base. And isolate the base means to isolate the base that contains the variable that you're solving for. And in this case, it already is. Step two is to rewrite logarithmically. Once you've isolated the base, you want to take your equation and rewrite logarithmically. I'm going to make a little note to myself here. Okay, so in the red are the steps, and in the black is going to be the work for this particular question. So you isolate the base, rewrite logarithmically. That in this case means this. Log base 2 of 1/16 equals x squared plus 5x. Okay, once you rewrite logarithmically, the final step is to simplify, solve, then check. So very important. Okay, so let's see. Simplify, solve, then check. Log base 2 of 1/16, what does that equal? Log base 2 of 1/16, yes, it equals -4. -4 equals x squared plus 5x. And what's beautiful here, and I mean beautiful, and some of you are rolling your eyes like, oh, she said beautiful. Okay, what's awesome here is when you have simplified, I want you to take a look at this for a second. This equation now is what kind of equation? It is quadratic. So in the course of solving an exponential equation, your equation may kind of shapeshift and change identity throughout the way. So here, in the course of solving this exponential equation, you get to a point where you have to solve a quadratic equation. And this quadratic equation requires us to think to ourselves, okay, how do you solve a quadratic equation again? Oh, we set it equal to 0. 0 equals x squared plus 5x plus 4. And you say to yourself, what are the ways that I can solve a quadratic? I can solve by factoring, I could solve by complete the square, I can solve by the quadratic formula, but once I set it equal to 0, if it's factorable, that's where I'm going to go, and here I am. Okay? And then I know x equals -4 and x equals -1. So I've simplified, solved, now check. The reason why you have to check your solutions in an exponential equation is precisely because of something like this happening. In the course of solving the exponential equation, it kind of changes identity. And when your exponential equation changes identity, or when any equation changes identity along the way, there's the potential of generating what are called extraneous solutions. You've heard that word before. Extraneous solutions are solutions that emerge mathematically, but they actually don't work when you check them out. So let's check x equals -4. When x equals -4, I have to plug it into the very original. So 2 to the, okay, so 2 to the -4 squared, what is that, x squared plus 5x, so minus 20, will that equal 1/16? Okay, let's see. Is that the case? That's the question. Well, this becomes 2 to the 16th minus 20, which equals 2 to the -4th, and 2 to the -4th does in fact equal 1/16. So that one checks out. How about x equals -1? 2 to the -1 squared, what is it, minus 5, okay, what does this equal? 1/16. Well, let's see. This becomes 2 to the 1 minus 5, which becomes 2 to the -4th, and that does equal 1/16. So now that I've checked, I can now proudly say that these are my solutions. Okay? So, solving exponential equations, number 1, isolate the base. Number 2, rewrite logarithmically. 3, simplify, solve, and check. Okay, what about logarithmic equations? Logarithmic equations. Steps. Number 1, get a single log expression and isolate it. Okay, well here there only is one log expression and it's already isolated. Aren't you lucky? So this is already done. And if you're wondering, can she show us an example of where it's not isolated, or where there's not only one log expression? The answer is, of course, yes. Step 2 is rewrite exponentially. So you see, notice any kind of parallel here? Logarithmic equations involve rewriting exponentially. Exponential equations involve rewriting logarithmically. So I'm going to rewrite this logarithmic equation exponentially. This says 3 to the 27th equals x plus 2. Okay, now without a calculator, I am not going to actually go and figure out what this number is, because it's 3 times 3 times 3 times 3 times 3, 27 times. But I'm just going to say at the end of the day, 3 to the 27th minus 2 equals x. Oops, I just missed a step 3. Step 3 here is simplify, solve, and then check. Okay? Again, let's take a look at this. When we rewrote exponentially, look at this equation right here. What kind of an equation is this? Don't you dare say exponential. The reason why this equation here is not exponential is because the variable you're looking for in this equation is not in the exponent. I'm solving for x right here. This equation just happens to be a linear equation. And linear equations are the easiest to deal with. Subtract 2 from both sides. At the end of the day, x equals 3 to the 27th minus 2. Simplify, solve, and check. And again, we have to check because, your equation changed identity along the way. It was a log equation. It became a linear equation. So let's check. Okay, we're going to check it. Let's see. Log base 3 of x is right here. Okay, so 3 to the 27th minus 2 plus 2. Does this equal 27? Let's see. Well, -2 plus 2, that just canceled out. So we get log base 3 of 3 to the 27th. What does that equal? This expression is asking you, what is the power that 3 is raised to give you 3 to the 27th? And what's the answer, everyone? it is just 27. And yes, this equals 27. So the solution is right here. X equals 3 to the 27th minus 2. Okay? So this screencast is about solving exponential equations and solving logarithmic equations. And hopefully as you go through this, that I hope it was like a suspenseful experience. Don't you dare roll your eyes at me. CJ, I know you are. Here, I'm going to have you solve this one. Solve this equation. I'm just kidding. I don't think you're rolling your eyes at me, CJ. Well, actually, I do think you're rolling your eyes at me, but I think you're rolling your eyes at me in a funny way. How about that? Okay. Okay. How about this one? Solve this one. Ready? Let's say solve for x, the natural log of x plus 6, okay, minus the natural log of 10 equals the natural log of x minus 1 minus the natural log of 2. Here's a special case. This is a special case log equation. The reason why it's special case, everyone, is because you'll notice that unlike this log equation up here, right? Like if you look at the log equation, log expression on the left, no log expression on the right. It's just a constant, right? This one, if you look at this, log expression on the left, and log expression on the right and on the right. Here is I'm going to write this down. All log expressions, and there's no constant. No, I should say no non-log expressions, okay? Like everything involved here, no non-log expressions. Everything in this equation here, all the terms, 1 term, 2 terms, 3 terms, 4 terms, they're all log expressions. And we love this special case, and it's going to be super easy, and I'll show you why. When you have a situation like this, what you do is the following. You get a single, which means 1, a single log expression on both sides. Okay? Get a single log expression on both sides. And I'm going to do that right now below here in black. I'm going to use the properties of logs to combine these two. The left-hand side becomes the natural log of x plus 6 all over 10, properties of logs, everyone, equals the natural log of x minus 1 all over 2. Okay? And then here's what's awesome about this. Boys and girls, look, if you have natural log of blah equals natural log of blah, the two arguments have to equal each other. So step 2 is just set the arguments equal to each other. That's it. Because you have a single log expression on the right, single log expression on the left, the base is the same of e. That means this argument has to equal the left-hand argument. X plus 6 over 10 must equal x minus 1 over 2. Okay? Now don't lose steam here, for heaven's sake. How do we solve an equation that looks like this? Some of you hopefully are saying you would cross multiply, but be careful please, when you cross multiply, do it correctly. 2 times the quantity x plus 6 equals 10 times the quantity x minus 1. 2x plus 12 equals 10x minus 10. Okay? 8x equals 22. 22 over 8 equals x is your final solution. All right? So this screencast was all about solving exponential equations and solving logarithmic equations. And you will notice that I'm going to look at the following here. This is your homework, okay? It is the following. Okay, this is your homework, everyone, right here, okay? A little hint for question number 45, this one, when you look at number 45, ask yourself, is the equation number 45 a special case? Yes or no? And if it's not, how do you get yourself to a single log expression isolated? All right? It was really great seeing you today. Really, really, really great seeing you. And I hope you have a wonderful evening. And I'll see you tomorrow. Goodbye.